Hello, everyone. Welcome to another episode of the Engineering Student Experience Podcast. I'm Paul Nissenson from the Mechanical Engineering Department at Cal Poly Pomona. Take a moment and notice the items that surround you right now. If you're at home, there may be pens, sheets of paper, various electronics like your phone, computer, or appliances. There may be shelving units with metal brackets and planks of wood that have books and other items resting on them. If you're in a car listening to this episode, you're surrounded by many pieces of plastic and metal and rubber that all serve a particular purpose. Wherever you're at, you likely are very close to countless components and machines that were manufactured. Since most products we encounter in our everyday life are mass-produced, this means that engineers likely were involved in setting up and maintaining the equipment necessary to create those products. In this episode, we're going to discuss the field of manufacturing engineering with Dr. Victor Okuisin, who's a professor in the Industrial and Manufacturing Engineering Department here at Cal Poly Pomona. Victor specializes in metal casting and has been teaching for 25 years. During the conversation, Victor describes the differences and similarities of manufacturing engineering with other engineering disciplines like industrial engineering, mechanical engineering, and materials engineering. At Cal Poly Pomona, students can get a degree in manufacturing engineering, but as Victor explains, there is a lot of overlap between manufacturing engineering and those other engineering disciplines that I just mentioned. In fact, there's so much overlap that in many universities, manufacturing engineering is a specialized track within another major, such as mechanical engineering. So at those universities, a student could get a bachelor's degree in mechanical engineering with a specialization in manufacturing engineering. Victor also discusses the types of courses manufacturing engineering students take and the type of math requirements needed for those courses. He describes the types of jobs that are related to manufacturing engineering in private industry, government, and nonprofit organizations, and he discusses the importance of getting advanced degrees. And finally, Victor provides some suggestions for all engineering majors on how they can put themselves in a good position to succeed in their engineering career. It's not all about getting good grades and internships, although those are important. Developing certain soft skills like oral and written communication are very important as well. One of the ideas mentioned by Victor that really stuck with me is that engineers are professionals, and students are frequently given an opportunity to practice professionalism when communicating with instructors, like when writing emails. As you might imagine, as a faculty member, I get a lot of emails from students. Many of those emails are written in a professional manner. The email starts with a courteous greeting. The body of the email clearly and succinctly lays out the question and provides the necessary supporting information. And the email ends with the student's name and perhaps some other identifying information. I also get emails from students that are much more like a text message with a lot of grammatical mistakes and a lot of important information missing. When I receive a well-written email from a student, and it's clear the student took the time to be professional with me, as a result, I'm much more motivated to write a detailed and thoughtful response. So now let's go to my conversation with Victor Okuisin. I hope you enjoy the conversation. All right, well, I'm here with Victor Okuisin, who is a professor in the Industrial and Manufacturing Engineering Department here at Cal Poly Pomona. And today we're going to talk all about his field of manufacturing engineering. So first of all, Victor, welcome to the podcast.
Well, thank you, Paul. It's a pleasure to be here.
So before we jump into manufacturing engineering, I think it'd be really helpful for the listener to get a little background information from you. So if you could just tell us a little bit about your educational background, how long you've been teaching, if you have any industrial experience or anything else that you think that would give the listener a little bit of better context about where you're coming from.
Sure. I come to this field in a different background, probably. My father was in the manufacturing field in metal casting. That kind of intrigued me. From that, I went and I studied materials engineering as my undergraduate degree, because that's something that you did at the time if you were going into metal casting. Then after that, I went and I did my master's and PhD at Penn State University. Oh, by the way, I did my materials engineering degree at the other Cal Poly in San Luis Obispo. And then I did my master's and PhD at Penn State University in industrial and manufacturing engineering. And because that gave me both the technical side of metal casting, which is largely encompassed within the materials engineering field, and also the other part of manufacturing, which is encompassed with industrial and that side of the field, industrial engineering and that side of the field.
How long have you been teaching here at Cal Poly Pomona?
My sentence so far is 25 years.
Oh,
yeah. Oh, yeah. I should also add, before coming here, I worked in industry for several years. And when I left industry to come to Cal Poly, I was the engineering manager at a mid-sized metal casting facility in Pennsylvania, probably about 120 employees total.
And I also know that you do some research as well. So what kind of areas do you do research in?
Most of it, well, all of it has to do with metal casting. And for the listeners, metal casting, if you haven't heard what it is, you basically melt metal. You make a hole of some shape, some useful shape. You pour the metal, you let it solidify, and you have the shape that you want. Very, very, very roughly speaking, that's what it is. Of course, there's a lot of permutations, a lot of variations in how you do that. So my research is anything that involves that. So I've done environmental research that goes around that. In some areas we have, for instance, one project that I did was how to replace SF6, which is a high greenhouse, a very potent greenhouse warming gas in the production of magnesium castings with other things that are more environmentally friendly. I am currently going to start working in a project that uses spent waste materials to be able to reuse it, something that is not currently being done. So that's one area. In other areas, I've done how to produce the product faster, better, cheaper, all of those types of things. I'm currently working on some alloy and process simulation and development, but all of this around the area of metal casting.
So if you could encapsulate the entire field of manufacturing engineering into just a few sentences, how would you describe it?
Well, first I would say, no, you can't. But let me give you a slightly longer answer. And if you want, we can go back to shorter sentences.
No, long's good too.
The manufacturing engineering is one of those fields that it depends on how you're approaching it. And there's three major areas on how you get into manufacturing engineering. Now, manufacturing engineering revolves around the stuff of making stuff. That's what it is. You're making things. Now, if you can come from it from the mechanical engineering side, but there you're looking more at the specifics of product design and how to manufacture it. Yes, you need to learn the basics and fundamentals of how to make it, but you're coming at it from more of a product design standpoint. You can come at it from a materials engineering standpoint, where you're still learning how to process the product and the manufacturing processes, but you're more concerned with the material properties and the impact on these properties of your manufacturing process. Or you can come in to it from the managerial or industrial engineering side, where basically you are learning how to manage the process. You still need to know how to make things, but here you're more concerned with logistics, how to set up factories, and so on and so forth. Here at Cal Poly, we are focused on that third area, where manufacturing engineering is within the industrial and manufacturing engineering department. I should say that most of manufacturing engineering does happen within mechanical engineering departments and not as a separate degree. Sometimes you get minors and so on and so forth. So for the listeners that are out there, depending on what it is that you want to do, if your interest gravitates between making things but also designing them, that's something that you should bear in mind. It is not necessarily while it can be a distinct field, it is closely interrelated to these other ones that I mentioned.
Here, let's just take it here at Cal Poly Pomona, where it's a separate program. What are the subdisciplines within manufacturing engineering? So you talked about like metal casting, and you talked about materials. I don't know if that's how you break them down, but like in mechanical engineering, usually we talk about like robotics and controls and thermal fluids and solid mechanics and materials. Yeah, how would you break it down in manufacturing? And then what kind of courses like would students be taking?
Yeah, well, we have a relatively small program in manufacturing. We get probably about anywhere from probably 20 to 40 graduates a year. So it's not a particularly large program. Because of that, we can't quite fully have full specialization tracks. So what we do here at Cal Poly is we train students to be independent learners, so that once they, to understand the fundamentals of manufacturing. So for instance, you will have courses that include machining, metal casting, plastics and polymer processing, composites, and so on and so forth. But because the industrial base of Los Angeles and Southern California is so vast, and it has so many different areas where you can go work, we can't really specialize you into any one of those areas because we don't know where you're going to end up. But the intent is that you will have the fundamentals. And let's say if you take our curriculum and you end up working at a forging facility, that then you will be able to grab the forging literature, continue your development, your technical development on your own. But you also bring a lot of other things. You also bring the ability to manage processes, the quality control aspects, how to set up a work layout, how to oversee safety, and all of those other areas that are common to all manufacturing processes. So we produce generalists that then have the ability to fully specialize.
So yeah, we already mentioned how here at Cal Poly Pomona, and actually where you got your degree, you also had an industrial and manufacturing engineering where you got your.
No, it's the same as here.
Okay.
It has two separate degrees.
So students can get a manufacturing engineering degree or a industrial engineering degree. And you've talked a little bit about how there's some similarities between them, but I'd like to just drill down a little bit more into the differences between the two. Why have two separate programs instead of like one degree? So what are the major differences between the two fields?
Just like I mentioned, okay, I'll explain that first in that context, and then I'll use the mechanical engineering example. In the industrial engineering, you're concerned with optimizing and improving things as a generalist. In the way that we teach manufacturing engineering, you learn how to do manufacturing engineering, and then you apply those industrial engineering skills to manufacturing engineering. So it does happen that our manufacturing engineers can actually graduate and go and perform industrial engineering jobs. And a lot of our industrial engineers do end up in manufacturing facilities. Both of these are true. But in reality, most of our manufacturing engineering students will end up in a manufacturing environment, whereas ICE can end up in many, many other areas, including things such as hospitals, food service, and so on and so forth. And it is unusual for manufacturing engineering students to end up in those positions. Not that they can't do the job. It's just that their interest is in making stuff. So that's why they gravitate towards manufacturing engineering. If in the case of mechanical engineering, the places that also do manufacturing engineering, you can have a manufacturing engineering track. And basically what you would do is, instead of specializing, say, in thermal or energy or mechanical dynamics, it's just another area of specialization that has more to do with materials transformation and making product. So it's just that.
Okay. Now in mechanical engineering, just if you look at the whole range of engineering disciplines out there, and I hope one day to be able to record an episode for every single one of them. So far, this is, I think, we already have an episode on mechanical, civil, aerospace, and I think this is the fourth one that we've done. But
that's it.
Well, we've recorded episodes on other things too. But
okay.
Yeah, it's not just all about the disciplines. But
maybe I should listen to your podcast.
Yeah. Why torture yourself? So if you look at, say, the math requirements, a lot of students get into engineering because they want to build something, they want to get their hands dirty, they want to manipulate things and design. But then certain disciplines like mechanical and electrical. Oh, we did an episode on electrical. I forgot about that. So we do electrical and mechanical. Those tend to have really high math requirements, and for some students that it doesn't work out for them for that reason. What kind of level of math requirements are there for manufacturing or industrial engineering?
Well, I wouldn't say that you have high math requirements as much as you have different math requirements.
Yeah, okay.
And because in manufacturing engineering, you're still going to do the 2-year calculus sequence all the way through differential equations and linear algebra. But that's where we separate. As my understanding is that mechanical and electrical engineers do more work in that direction, whereas in industrial and manufacturing engineering, we move more towards statistics. And statistics is a main branch of math that we use. So things such as quality, the course is statistical quality control, and we're looking at variation, we're looking at population distributions, and those types of things. So it is not, so it's just a different type of math. And for your listeners, another thing that I get asked a lot, how good do you have to be at math? Because there's this perception that for engineering, you have to be a math genius or otherwise you're not going to cut it. In my experience, and this is not just for manufacturing engineering, but for all engineerings, if a student is generally maintaining a B, can get B's in math without too much difficulty, say through junior high and high school, etc., and they just continue advancing to the next math class, that is generally more than adequate. The better you are at math, the easier it is, but you don't have to be a genius. And I've met a lot of people that get scared about this. It's just another class. Yes, it could be a harder class, but it's just another class.
Yeah, and while there might be lots of linear algebra and differential equations and all those kind of things in the classroom, it often just comes down to like some algebraic equation that you use when you're designing something in the end. So
most of the math is actually algebra, as it turns out, and as it turns out even more, we use a lot of computer tools now, where we actually are using the calculus and we're using those kinds of things to understand the phenomena that's happening. But then we go ahead and we use a spreadsheet to solve it because it's just easier and faster.
So a lot of the different career options that you mentioned for manufacturing and engineering students already, they all seem to be in the private industry. Is there government jobs that
yes,
for manufacturing engineers?
There's government jobs and there's some nonprofits as well. But we are clearly dominated by the private sector for the for-profit world. In the government, you have people that do research, you have people that do regulation, and I have a student that currently works for the Air Quality Monitoring District here in Southern California, doing air quality management. So no, there's work there. There's in the military branches, or within the military, the governmental structure of the military, there's a civilian side, and well, all the military hardware needs to be manufactured. And one of my students, a very successful student, fantastic student, she is currently, the last time I talked to her, she was overseeing all non-nuclear munitions for the Air Force.
Okay, wow.
So yeah, I mean, extraordinary person. And she's fully a civilian. So that you have national research labs if you're into research. And because manufacturing overlaps so many other areas, there's a lot of work that you can do in government. In terms of NGOs and those types of things, nonprofits, you have professional associations, and where several people go work, but you also have people that are trying to do, say, more sustainable development of things. And they may be in the NGO world rather than the for-profit world, but most of our people do end up in the for-profit.
So to give a kind of a concrete example of what a manufacturing engineer might do on a particular project. Let's say that you have some company like Frito-Lay. They have a new chip that they want to bring to full-scale production. They've already tested it in their little kitchen. They like it how it is, but now they want to make millions or billions of these chips a year. How are manufacturing engineers, or where might you find manufacturing engineers in this process, and how might they be interacting with other engineers who would be helping bring this to fruition?
In the skill set of manufacturing engineering, you're going to see work area layout. So they're going to be, they have the ability to design the actual facility where this is going to be happening. They have the skills to understand and specify equipment and equipment characteristics. So as this new line is being developed, they will be able to indicate what it is that's required of the equipment to the actual equipment manufacturer. They will be able to set up the quality control procedures and tests to ensure that you have quality. They will be able to set up the automation, because Frito-Lay is going to be a very high production environment, so it's going to be more than likely fully automated. So they will be able to do all the automation interface, and they will be able to look at the economic aspects of the process. That's a very important thing. Look at the return on investment, look at which choices are the ones that are more financially beneficial to the company. So they will be able to do that. They will be able, well, you mentioned that the recipe for the chip has already been developed in the kitchen, but they will be able to translate that to change the parameters as they may be needed to have a successful chip at the high volume production, because there's typically some adjustments that need to be made when you do those things. So they will be able to handle all of those things. They also have the ability to do forecasting and demand planning, those types of things, figure out how many people need to work in the facility, what ancillary items you will need, like for instance, packaging equipment, all the way down to forklifts if necessary. So all of those requirements. While we don't necessarily go all the way down to how much electrical power the entire facility is going to need, we certainly can go down to the level of how much a certain production line would need and what utilities, those types of things.
Okay.
But then they would work with architects, civil engineers, and so on and so forth to provide all of those things to them.
So it sounds like they could pretty much do almost all of it.
Well, this is where the different engineerings meet. Like for instance, I said that they can specify the equipment, but a mechanical engineer is going to be better at designing the equipment, right? And a different kind of a manufacturing engineer is going to be better at actually building the equipment and then putting it in the facility. And for automation, you're going to rely a lot on information technology specialists, a lot of electrical engineering work in those areas, particularly in the area of sensors. But as you mentioned previously, mechanical engineers also handle some of that. And that's one of the things within all the engineerings. You have a lot of overlap between the various engineerings, but depending on how complex a task is, the more you need a specialist in that area.
So if I had a group of a dozen manufacturing engineering students right now,
you would be blessed.
What recommendations would you make to them to put themselves in a good position to get a decent paying job, a good job that they'd be happy with immediately after college? So would you recommend that there are certain clubs that they join, or internships, of course, just so you can have that on your resume, and I would imagine grades, having at least a 3.0 or something like that?
The bigger, right now, the largest differentiator is having what people call soft skills or lifelong skills, communication, the ability, professionalism, showing up on time every time, prepared for whatever it is that you're going to come and do. An internship has been a big differentiator in the few recent years, where the more internship experience that you have, the better off you will be in terms of positioning yourself. High grades never hurt. Now, what would I say is more important, high grades or an internship? I would say that probably the lack of an internship probably is worth about half a grade, a 0.5 in GPA. So I'm not saying do one or the other, do both. Be a resourceful, independent learner. That's going to be the key to anybody's career. As the world is moving and changing faster, you need to keep up with all of these things, with all the changes faster, and that becomes a significant challenge. You need to be able to process information on your own without having an instructor pre-digest it for you. Now, clearly we were talking about math earlier. Some concepts are just really hard. So yeah, that's what we're here for as professors. But once you go into the professional world, you need to be able to grab an industry journal, an industry magazine, and distilled information that is useful to you, and be able to, and you have a particular problem, let's say you're making potato chips. So you need to be able to go to the Journal of Potato Chip Making and be able to figure out what exactly is the issue or what information you can grab from there that you can apply to your process to make it more successful.
So you're mentioning soft skills. Do you have any recommendations of ways that students can help develop their, communication skills?
Sure. Go to, there's the National Association of Colleges and Employers, NACE, and they have what they call career competencies. Look at those, and I particularly like that website because they have all of these things, and it's technology, professionalism, oral communication, written communication, and several others, teamwork, leadership skills. And in addition to the definition, they have the types of behaviors that represent that you have those skills. Be intentional about developing all of those behaviors. So if you have a team project in one of your classes, try to emulate the positive behaviors for leadership and teamwork. In your communication, always practice being professional. One of the things that students often forget is that they are professionals. Their profession currently is to be students, but they treat communication often too informally, which is problematic at times, but also they miss the opportunity of practicing how to communicate professionally with their instructors and so on and so forth. So look at what those skills are and be intentional in developing them. You start a class, look at the syllabus and say, which of these skills can I develop in this class? Now, our job at the university is to make sure that once you're done with our curriculum, you have developed all of those skills. But you will get further ahead if you actually know what you're doing and why you're doing it.
Yeah, I mean, when I get emails from students, I can definitely, you have some students who write these very well-crafted emails that are respectful. They have like a dear so-and-so and an ending that and then you have some others that are like 3-word, like, hey, what's this? And it's like,
correct.
If you start doing that kind of thing on the job, that's going to be noticed by your
Correct.
bosses for sure.
Yeah, professional communication is not a text to your friends.
Yeah.
and the other thing that you need to bear in mind is when you're doing the written communication, you're providing information that other people can later refer to. So it's two parts. One is to convey an idea, but also when you're conveying the idea, make sure that you put enough information there so that the person doesn't have to keep going back and forth and so on and so forth. One of the problems that I see is people emailing back and forth with instructors if it's a conversation. It is not. A conversation is a conversation. An email is a different type of message where you should lay down all of your questions neatly, clearly, and then you should, in response, get succinct and complete answers to your issues. Now, if after that raises other questions, okay, then you continue. But a lot of the times it's just not thinking about what's going to happen next or how can I prevent this back and forth, that in the end wastes not only the student's time, but also other people's time. And that's what you need to be mindful of.
Yeah. Although I also must say that there are some faculty that I've run into that also could improve email skills. Not you, of course.
Oh, of course not me. Yeah. No, no, there is everything under the sun. I mean, no organization is perfect, and that will apply to any employer. It will apply to any school of our size. And, what can I say? I did have more than one teacher that I didn't like. I did have more than one teacher that I absolutely loved, right? And a bunch in between.
Yeah, I'll put a link to the NACE website in the show notes.
Yeah.
So when the students, typically when a manufacturing engineering student gets their first job, right out of college, assuming they go into, private industry, what's the range of typical salaries that they might be expected to get for Southern California salaries, let's say?
You're catching me at a bad point because I normally ask that at graduation time, which is in 2 weeks for those of you listening to the show. And that's how I get my bearings. But I think this year's going to be in the 80,000s.
Okay.
But that's a guess. Anybody listening to the show, perform due diligence. But what I have noticed in comparison to other engineerings, except for petroleum engineering and chemical engineering, because I also end up working extensively in the oil and the petroleum world, the salaries tend to be fairly comparable. 1 year mechanical engineers will be a little bit higher by a couple percentage points than electrical engineers, then sometimes it's us. But generally, they all tend to be about the same.
Yeah, I think mechanicals typically ballpark is 70, 80,000-ish last time I checked.
I think this year you're going to be seeing higher salaries than that.
Inflation.
Amongst other things, yeah. Well, and for the listeners of your podcast, there's an endemic shortage of engineers. I mean, I would love to say that, we are fantastic, therefore we get paid a lot. And yes, we are fantastic. But there's also more demand than supply for engineers right now. And I don't see that changing in the next 10, 15 years. And with regards to manufacturing engineering, there's probably about 80 graduates in manufacturing engineering in the entire state of California a year. So yeah, there's only 3 programs that I know of that are manufacturing engineering. Now there's also manufacturing engineering technology, and there's a few others of those. And you also have people that are maybe within a mechanical engineering curriculum that end up doing manufacturing engineering. But just manufacturing engineering per se is about, I would say, no more than 100 a year in a typical year. And that's for the entire state of California. So our students routinely do not struggle to get jobs. But a lot of that is just scarcity.
Yeah, actually, I was just in preparation of today's conversation, I looked at the Mechanical Engineering Professional Society, which is ASME's data on where do mechanical engineers wind up. And actually, one of the largest fields is in manufacturing.
Mm-hmm.
So, absolutely.
Yeah. And one of the things that I tell my students is when they're looking for a job is also look at the mechanical engineering jobs, because a lot of employers, again, manufacturing engineering is so small that a lot of employers don't know that it's there as a field. So if you look at the job description, it reads like the manufacturing engineering curriculum, but they're advertising for a mechanical engineer. And so that's a reality. Now, I have worked with mechanical engineers in my industry practice, and depending on what it is that you want to do and how you trained as a mechanical engineer, you could be well prepared or not well prepared for the manufacturing world. So just be aware of that.
So in certain fields like civil engineering, getting your PE license, to be professionally licensed, is really important. Mechanical, it can be, or it might not be, depending on your area you go into. How about in manufacturing engineering?
To the best, I believe, this is information from several years ago, but I believe that the state of California discontinued the PE on manufacturing engineering because there was so little demand, because in reality it doesn't matter. I mean, if your PE in manufacturing engineering is better, it's not going to get you better jobs, it's not going to get you better assignments, it's not going to get you other things. And a lot of that has to do with other things. Like, for instance, a manufacturing engineer should have a certain amount of training in safety. But the reality is that safety is so closely regulated by OSHA that it becomes a I mean, it's not really going to be a certification that's going to have the legal implications that a PE would have, say, for somebody designing a bridge. If you can get it, I would say definitely go ahead and get it. Second best option is to obtain a certification from the Society of Manufacturing Engineers. And in terms of employment and those types of things, that has the same respect. It does not have the same legal aspects that the PE license has.
So how about getting an advanced degree, like a master's degree? What kind of doors does that open up? Is it really helpful?
I am of the view that this generation, and I presume that your listeners are, for this interview, are people thinking about getting a college degree, is that in order to advance, you will eventually need a master's degree. If not, you will hit a glass ceiling. And so I think it's pretty much essential. The real question is on what and when. Do you get it right after you get your bachelor's degree? Advantages and disadvantages. If you get a little bit work experience prior, you will get a lot more from your master's degree training. However, the longer you're out of school, the harder it gets to get that second degree. One of the things that happens in the engineering world, but certainly in the manufacturing world, is a lot of employers will pay for you to go to school. And typically you get a lot of degrees that are evening type programs where you take 1 or 2 classes at a term and take a little bit longer to graduate. So that's not an uncommon path. In terms of a PhD, if you want to do either research, and again, this can be done at companies, it can be done in universities, it can be done in federal labs or those types of entities, or if you want to teach at the university or college level, that would be a reason to get a PhD. If you don't really want to do any of those things, maybe the PhD is not for you. Having said that, if you do want to get a PhD in engineering, it is relatively doable to get somebody else to pay for it. So finances should not be part of the equation. Now, you may not be getting your PhD at MIT. You may be getting it at an institution that you never heard of before, but hey, they're paying for it and it's still a PhD and it still has the rigor that you need to be recognized as such.
So yeah, we're about to have graduation soon, just in a couple weeks. You're gonna have a group of students who get their bachelor's degree and are ready to enter the workforce. Some maybe already in the workforce. What are the typical kind of jobs that you see manufacturing engineer people get their bachelor's degree like go into right away?
Let me talk about it in 2 ways. One is the field that they end up working in, and the second one is the position that they end up working in. In terms of field, I've had students that make pig tissue heart valves, for instance. We clearly don't train them to do that, but they learn the skills that they, to be able to develop themselves to do that job. One of my alumni is director at one of the leading heart valve manufacturers, the director of manufacturing. I've had other people that I had a student that went from making composite materials to making ocular eye implants to then making aircraft components. So that is a generalist view of all the things that you can do with this. I have a couple people that have gone one into the food area, one making frozen burritos after having spent some time making metal castings. I have another one that went directly into the supply chain for Panda Express, for instance. So the food supply to their stores. So they can go into heavy industry to make automobiles, to make cars. You can go into electronics, plastics, etc. I mean, anything, if it's made, you can go there from here. In terms of position, you can go the technical route where you're the technical specialist on how to make things, how to set up the facility, how to make those things work. Or you can end up immediately in a supervisory position where you're actually supervising a production line and managing some people. Of course, all of these things will depend on what type of experience and what type of place you end up working in. You could end up working in a small mom and pop shop, and I've had some students that just really like being there. The advantage being you can do a lot of things. You can be the quality control person, you can be a little bit of the salesperson, you can be a little bit of the manager, a little bit of the technical person, or you can go into areas into much larger companies. Like for instance, I have some graduates that have gone to places like Boeing, where they are part of a design team, and their specialty is the manufacturing side of that team. And you have other people that may be the thermal specialists, other people that may be the electronic specialists, and these are the people, but my graduates are the ones that say, okay, how are we going to make this? Let's make sure that the design makes sense from that standpoint.
Well, Victor, thank you so much for giving up your time today to have this wonderful conversation. Before I let you go, you mentioned how there was a shortage of manufacturing engineering students and just engineering students in general. If I could get a group of 20 high school students into this room right now, and you could give an elevator pitch for why a high school student should consider being a manufacturing engineering major in college, what would you say? Who should become a manufacturing engineering major?
Well, this is actually, curiously enough, a very personal question. My daughter just graduated as a manufacturing engineer, and the reason I felt that she should consider that as an option is because her entire life she was always making things. She just really liked making things. And that would be really the main characteristic. If you liked making things, that's why you would go into manufacturing engineering. Now, one thing that I would also like to point out, and this is not just manufacturing engineering, but all engineerings, a lot of people don't think of engineering as being a very creative field. People think of the arts as being creative. Engineering and manufacturing engineering is very creative, but in a different way. We're creating a better world for everybody in many ways, shapes, or forms. These days, it happens to be electric vehicles, as an example, that will eventually be self-driving. That's a very creative thing that we do for society. So a lot of people think of engineers as just being people that sit behind a desk and just crunch numbers. No, it's a lot more than that.
Yeah, it's inventors.
Correct.
Yeah. Thanks a lot, Victor. This was a really, really wonderful conversation. I'm sure our listeners are going to learn a lot about your field, and hopefully maybe one or two of them out there, maybe sometime over the next few years when someone listens to this, maybe some will decide to join your department.
Okay. Well, I hope so, and we'll be waiting for them. And I thank you for the opportunity, and I will be waiting for their royalties.
Keep waiting. Thanks again to Victor for joining me to discuss the field of manufacturing engineering. In the show notes, I've placed a couple links. The first link is for the National Association of College and Employers, also called NACE, which discusses career competencies. Victor suggested that students should be intentional about developing those competencies in those courses and not simply be focused on learning the course material. The second link shows the different types of field mechanical engineers work in and highlights that many mechanical engineers work in a field related to manufacturing. Before I go, I'd like to mention that if you're enjoying this podcast, there are a few ways to support it. You can subscribe to the podcast using your favorite podcast apps, such as Apple Podcasts, Stitcher, Google Play Music, Spotify, and many others. You can rate the podcast and leave comments on whatever app you use to listen to the podcast. And finally, you can help spread the word about the podcast by telling your friends and family or anyone else you think might be interested in this podcast. If you have any comments about the episode, feel free to email me at tesepodcast@gmail.com, and I'll place the email address in the show notes. I will personally read each email and try my best to respond to them all. Well, take care, everyone, and goodbye for now.